Good afternoon, and this is Module 8, which is responses to disturbances. So basically what we're looking at in this section, this module, is how ecosystems respond to stress. So basically, if we think about this question here on the slide, there's two questions, but what is the difference between resistance and resilience? So basically, resistance would be the ecosystem not changing. So let's say that there's severe drought. And if all the plants are adapted to severe drought, then that would be resistance. So the plants will remain, nothing's going to die. The species that are involved with those plants remain the same. And so that would be resistance. It doesn't change. Whereas resilience would be coming back from some kind of disturbance. So think about, for example, the car fire. So you can see already after 2 years, some of the trees are, 6 feet tall already. And a lot of plants are coming back. In a couple more years, it's going to look really good around here. And then, maybe 15, 20 years, it'll be hard for somebody that isn't in the area to even know that that happened, except for, there might be a few dead trees around. But as far as the vegetation goes, it's going to be coming back really nicely. And so that's resilience. So all of the trees around here, the oak trees, they're growing from the roots. Manzanita is actually really prone to fire areas, and that's already well established and coming back. The grasses have come back. I don't know if you guys noticed, the wildflowers were crazy abundant in the last couple of years. And so that's just resilience. So things are adapted to that environment and they come back very fast. Whereas resistance would be that they didn't go away in the first place, which is hard with a fire. But we're talking about, drought or something along those lines. So the characteristics of that would be resilient, would be like I mentioned with the oak trees, with the manzanita, with the wildflowers. Some pine trees, actually all pine trees, need a fire in order to germinate with their cones. So little things like that. So that would be resilient. And it's well adapted for our fire-prone areas in California. All right, and then this was a kind of interesting study. So this was a study that a teacher actually did in an area that they were studying watersheds. And they got together with some researchers, some universities, and some logging companies. And so they did this study, and it's called the Hubert Brook Ecosystem Watershed Study. And so what they did was they had a few controlled watersheds. So as you guys learned, watersheds are areas basically from ridge to ridge, and all the water, if it was to rain in that area, would funnel down into the valley. So between ridge and ridge would be your watershed. So basically they took these controls. So they had a control, meaning that they didn't do anything to it. And then they had this watershed that was logged, so basically clear cut. And then they had this watershed that was logged, and then they sprayed it with herbicide just to see the difference. And so what they found was a difference in nutrients. So plants actually stabilize the nutrients in the soil, and they also stabilize the soil, which we'll learn later. But we're looking at nutrients mainly with this study. So they found that calcium levels were elevated in areas where it was clear cut versus sprayed. And where it was selectively cut versus clear cut. So they just found that the areas that were more disturbed were also more disturbed nutrient-wise for the soil as well. So that helps them to understand, better logging practices maybe. So instead of clear cutting, maybe selectively cutting old growth, or something like that, it's very important. It's not just aesthetically important, but it's important for the entire watershed. I also mentioned that the plants hold soil. So in this watershed, being completely logged, clear cut, you would expect that the soil would not be held. So if it rains hard, a lot of the soil is going to settle down into the valley. And that's what they were really worried about the first year after the car fire, with nothing on the ground and lots of rain, is that we had the potential for a lot of mudslides and landslides. So these watersheds or these areas are disturbed. So here in Redding, we had a great example of disturbance. So a major event that caused a major disturbance. And now we can see restoration ecology right in our back door. So we can see how things are coming back, how things are being resilient right here in Reading. So looking at the watershed, here's the ridge line, and then here's another ridge line. So the water, because it travels downhill, once it hits a ridge, is going to travel down into this valley, and same with this. So we can think of this as like the Sacramento River, for example. So here's the Trinities, Mount Shasta maybe. And then you can see the water is shedding, so it's traveling down into the river. The river widens as it gets farther downstream because it's carrying more water. But that's our watershed. And so there's lots of watersheds. So if you look at a small picture, between each ridge is a watershed. So essentially between the ridge to the right, the ridge to the left, there's a watershed that dumps down into maybe a creek. But then those creeks eventually dump down into major rivers like the Sacramento River. So if we're talking about watersheds in general, we're talking about a huge, large area. So on this map, I know it's a little bit blurry, but you get the idea. So here we are here. So think about the big picture of mountains that we have. So we have the coastal range here, and then we have the Sierra Nevadas over here. So this is a major watershed, and this happens to be the Sacramento River. So all of this water sheds down into the Sacramento River. And then we've got a couple other river systems down here. Mainly down here, we have the San Joaquin River, and then those filter together into the bay. And then there's a couple other watersheds over here. So these are major watersheds in California. But like I said, we also have, hundreds of smaller ones from ridge to ridge that are funneling down. But ultimately, even though there's ridges here, ultimately they funnel down into the bigger picture, which is the Sacramento. So in California, these are our major watersheds. And those are pretty important because you can see, just looking at this picture, they feed the valley. So the valley is fed with all of this water. So that's why snowmelt and things that they talk about is really important for not only our produce, but also just the fish that rely on the river and the water supplies that we have in general for people. All right, and then this last little bit here, this is a very short note section, but this is just talking about disturbance. So let's say that we had a small disturbance. So just something really minor, maybe a heat wave, extended heat wave for a week or so. So that would be a low disturbance, and maybe it's not very frequent. So maybe every 5 years that we have a low disturbance like that. So what you're going to get, we're looking at species richness. So species richness would be very low. So we wouldn't have a very big abundance of organisms. But then notice how if there's a slight disturbance, so maybe every 10 years we have a fire, not a major fire. We're not talking car fire, but we're talking, just a normal fire that's normal for the ecosystem. So that would lead to a lot of species richness, which is biodiversity. So that's actually good for the environment to get small disturbances here and there. And so we're kind of learning that more and more as humans. For a while, we'll talk more about fire, but for a while we were suppressing a lot of fire, and that's actually really not good for the ecosystem. The ecosystem really relies on that, not only the plants reproducing, but just the ecosystem in general to keep things healthy and in check. So minor fires, like what California is prone to naturally, that leads to a lot of species richness, surprisingly. But if we have a really high intensity event, even if it's infrequent, then you're going to get a big drop off of species richness. So the sweet zone, in a sense, is right here where you have kind of an intermediate disturbance periodically. And so this gives an example of a snail. So it talks about the amounts of snails per meter squared compared to the richness of the algae. And so if you have a higher density of snail population, you actually have a higher species of algae. So they kind of are balanced together there. And then if you don't, then you have either one end or the other as far as the types of algae that you'll see. So you can apply this graph, this kind of generic graph up here, to anything. So like I said, it could be fires for disturbance. It could be organisms. Maybe if we have a high amount of deer one year, then that kind of factors into how many plants we have or how many mountain lions we have or something along those lines. But intermediate disturbance, this is a hypothesis, but intermediate disturbance, which is right here, would be what we're looking for. So kind of mid-level frequency with a lot of, mid-level frequency anyways, would give you good diversity, so good species riches. All right, and that is it, very short. So I will see you guys next time.